All right, great. So now we're going to talk about starting a project, and that's really initiating the file, but it's also really about making sure that we are going to put in design rules that fit our manufacturing process that we're trying to design for, right? So if we're trying to make this for the Makera, we need to make sure it's actually possible to mill it. And it's very easy to create features that are way too small for what our Makera can do. So it's very important that we load these design rules in the first place. And the other thing that we care about is loading in our board stack and making sure that the board stack that we design for is also the same as for our manufacturing process. So we're going to cover starting a project and these two sort of setting up the board and the tolerances and design rules in order to make sure that everything works the way that we want it. So when we are greeted with our KiCAD screen, we can click this little button here to create a new project. I would generally suggest if you're in a folder like a KiCAD project folder or something, you may want to come to some root and create a new folder for your project. It's typically a good idea. So we'll just say Forge demo, um, and we'll save this as a Forge demo project. And you can see it immediately opens a project file here, and it gives us a PCB file and a schematic file. So we already have our two linked design and then the sort of realized board files that are blank that have been created for us. So that's wonderful. We can go in if we want, we can start placing parts and then update our PCB from our schematic in order to get over to our PCB editor or just switch over to our PCB editor. And now we're in the matching PCB file to the schematic file, right? So these are the same. That brings us to this nice PCB file, which we can also just directly go into. Now to set up our board, what our thing is capable of doing, right? So as we know, when we open this, sort of the main thing that we really need to pay attention to is which layer we are on and designing for, right? So anything you do, you can put text, you can put it in copper and it will mill it out of copper if you put it on the front copper layer or the back copper layer. You can put it in the silk screen and it'll draw it on if you send it off to a board file, and that's the same text. So we really care about what layer we're on, and those layers match uh, the layers on top of the board in our stack up, right? And when we're designing as well, right, we have a front copper layer and a back copper layer like this board. So this is a two layer, actually this is a three layer, a four layer board. But if we have a single sort of simple two-layer board that just has copper on top and bottom, that's what it's given us, right? Just front copper and back copper. There's no middle layers of copper here. But if we change our board stack, we can actually add middle layers of copper so that we can get, this kind of a thing and design these inner layers as well. And then we'd be able to switch in between those layers of copper, just like we can switch between these two layers of front and back copper. So the place we need to go to set up our project is the board setup in File, which I believe, I'm curious if this works from our schematic side. No, right? This is for the schematic setup. So we need to be in our PCB file, and then we go to File Board Setup, and now we get our board stack up and our design rules, right? So um, one of the nice things here is we have import settings from another board and we can just pick an old project. So what you'll probably end up doing is doing this once ever and then editing an old file or importing the settings from another file. So you really only are going to have to do this once, but you need to make sure when you start your project up, you import your settings and you have them correct. And so you can see if we look at our board stack up, right? We have our basic layers. Really, you're not going to do anything different for this for now, but you can go in here. This is probably a slightly easier menu to start with, and you can say like, I need a 4-layer board, and it's going to give you a pretty strong starting point for 4-layer, 6-layer, 8-layer board, right? For our physical stack up. And then we can go to a board house that we might want to use and look at what they offer us. So we're going to start off, we're going to use Osh Park because that's a pretty easy one um, to take a look at. And you can see we already have, um, they have a 6-layer service now. They'll tell you how much everything costs, a 4-layer fast service, et cetera, et cetera. And these are all the different services that they offer, a 4-layer service. So if you want to do a 4-layer board, go for it. If you want this, this is a twice as thick copper, 2-ounce copper. So we typically talk about copper in ounces. Um, this is the typical board is 1-ounce copper, which is it's like a dumb way of defining it, but it has to do with how much copper is actually put onto a certain size board. Um, but so this will actually tell us if we click on one of these. So let's just pick one. Let's do a 2-layer board because that's probably what you're going to want to do. 4-layer Super Swift. Where's like the standard services after dark black prototype? Our classic 1.6 PCB 2-layer prototyping surface. Okay, so this is our sort of standard. That's what the board will look like. It's gorgeous. They do a great job. They're relatively cheap. Um, Made in the US, wonderful. You can see all these things about it. And it tells us right here what the stack up is. So, this is a nice place to start because Osh Park will tell you explicitly. For some of these other board houses that are more complex, you can decide more. But this is a good place to start. So we can see that we have 1-ounce copper, which is, 0.0356 millimeters. And look at that. That matches exactly what we have here. It'll tell us our solder resist, our solder mask, and how thick that is. So that goes here. That's this mask, 0.01 millimeters. It tells us our silk screen, and we can see, and then there's a core that is 1.52 millimeters, right? And our tolerance. So we can just literally drop these in and you will notice that all of these match exactly this because this is the standard board stack up. So there's nothing you need to do if you're going to do a very simple 2-layer board here, but this is where you would go if you want to change your physical stack up. And this is a good thing to start with. Think backwards, make sure that you understand what you're doing. But in general, all you're going to really need to do is click 2 or click 4 and pick what you want. Okay, and then we'll move on to design rules, right? So this is where you really do need to pay attention. And you can see there's a couple very important rules here. Probably, so for the Makera, you can see we've defined this sort of minimum clearance between two traces, the minimum width of a trace, the minimum size of any font, the minimum size of any hole that it's going to be able to do for us, right? And everything is 0.2, 0.2, so our minimum clearance between two things needs to be 0.2. Our minimum track width needs to be 0.2, and that's if we're designing for the Makera, right? Our minimum annular width and diameter, so let's see. Our minimum through hole is 0.4, and you can see this is actually says 0.3, so that's not good for us. We should, so this is where, you should go in and just kind of like tune things up. 0.1 feels a little tight, nothing is 0.1 for us. So the annular width, which is like this amount of copper left around that hole, which you can see represented in the little icon, that feels a little tight. So maybe we do 0.2. Yeah. So we just kind of go through and fix these up. And it's really the copper that we care the most about. And so, yeah, minimum connection width. Probably everything should probably be a minimum of 0.2. We also have text and graphics, right? And we can set the line thickness and text width and text height. And we can see it is telling us for a silkscreen layer here, it has given us a demo of at least 0.25 millimeters tall, probably. So this is fine. I think this should be fine. Maybe that's thickness. It's actually hard to tell from their little thing. But you can play with this. If you want to be uber careful, maybe you make this 0.25. And this is where we sort of set all of these different things and make sure that we're going to be okay. So that's if we're designing for Makera, we're going to be very generous and try to make features a little bit bigger and no hardcore corners. We want everything to be, 45-degree angles and sort of gentle as much as possible because, it's very easy to mill out stuff that you don't mean to mill out, particularly if you put things too close together. So keep that in mind. Uh, the nice thing about Osh Park is that they actually have, and I'm just going to Google it, Osh Park KiCAD design rules. And the first thing that pops up is literally a KiCAD design rules setup that we can see, and it actually tells you go to File Board Setup. Most values have conversions, but KiCAD will automatically convert to your preferred units, and it will tell you exactly what you should do and exactly what you should type in for your two layers in order to be in spec for what OshPark offers. So again, this is a very nice, simple way to make sure that what the board that you make can come out looking absolutely gorgeous and get uploaded to OshPark and be okay with their design rules. So once we've done setting that up, we hit OK. And the nice thing is when we start drawing traces on this page, they will automatically match our requirements. If we like finish a trace and we try to draw another one near it, it should sort of bump it away once we've defined traces so that it knows that this isn't the same trace as this. So the problem that I'm running into here is it doesn't know that these shouldn't touch. But as soon as we connect them to pads and it knows that they aren't supposed to touch, it will make sure that we don't get close enough to that trace to be out of spec with our design rule. And then we can run our design rule checker at the end, um, which is I believe, inspect design rule checker, and it will actually test everything against the parameters that we've set with our design rules. Okay, so that's a basic, quick intro to setting up a board. So just to refresh our memory, the main thing is we click here to start a new project, give it a new folder. It's going to give us these two, the PCB file and the schematic file. And then we're going to go into the PCB file. We'll go to File, Board Setup, and we'll put in our physical stack up, and we'll put in our design rules, particularly focused on the copper design rule constraints and the holes for you guys. And that should match what Maycara says and or what OshPark says. And Maycara is going to be more aggressive because our tools are much less precise than what OshPark offers. So if it works on our Maycara cam, it will work for sure when you submit it to OshPark. All right.